So what I have done is made an affordable exoskeleton that tracks the angle of a knee as it extends and flexes throughout its motion. The goal is to be able to use this data to then create an analytics-based platform that stores all of this data and can analyze it to compare needs, compare results from one person to the next to see where that person can improve. So this exoskeleton is worn on the outside of the knee, and there is a tracker in the middle joint that tracks the knee angle measurements as it goes through its motion and stores it to an app. And then on the app, you can compare it to a variety of different, you can compare it to a control of a set of normalized data to see where the discrepancy or deficiencies are in your data and where you can improve. And in this way, you can help determine health recommendations, assist in diagnoses, or discover areas of improvement if someone's uninjured and they're doing it for injury prevention purposes or something of the sort. And through this app, the goal is to connect patients with the appropriate information, treatment, and doctors. They can use the data they have collected themselves through the device, compare to find where they have deficiencies, and connect with other people maybe of a similar that have similar injuries or similar problems, or they can identify doctors or treatments who can help them to create a plan of improvement, whether it be physical therapy or doctor intervention or something of the sort. Connecting straps. These straps connect the leg of the user to the device with a simple snap of the buckle. They can be tightened and loosened to fit every size and are made of soft fabric for comfortability. Adjustment points. These pins act together to connect the leg straps to the main area of the device. They are formatted in a way to allow for customizable angles and distances to fit comfortably on varying sizes of legs. Telescoping points. The telescoping points on the design allow for greater adaptability of the product. By removing a pin, the user can modify the length of both the upper and lower arm of the KnexFlex and lock it back into place when ready. Telescoping pins. These pins are small pieces that can be easily placed and removed from the telescoping points. They are used to hold the parts in place when it is locked and to maintain the stability of the device. Arm connectors. These inserts allow for the arms of the device to connect to the center pivot point through interference fits. They are then glued into place to maintain a permanent hold. Pivot point. The pivot point rotates in a circle to allow for 140 degrees of motion. It has a three-part design that can be rotated when needed simply by spinning the bottom piece. This enables a user to wear the device on either leg. The pivot point is also where the encoder is stored to measure angle data. Electronics. The electronics consist of three main components: the battery regulator that maintains the proper current of the system, the ESP32C3 microcontroller that operates the system, and the AS5600 magnetic encoder that records the angle of the knee.